Now we will see second problem on the root locus. Sketch the root locus for the system GSHS is equal to K divided by S into bracket S square plus 2S plus 2. Therefore, we will see the solution. GHHS is equal to K into bracket K divided by S into bracket S square plus 2S plus 2. Now, step 1 again, calculation of number of poles, number of zeros and number of branches. Here, denominator of the given function is S into bracket S square plus 2S plus 2. Equating it to 0, we will get poles, that is S into bracket S square plus 2S plus 2 is equal to 0. Therefore, first pole we are getting as S is equal to 0, and we will solve this quadratic equation. S square plus 2S plus 2 is equal to 0. Therefore, S is equal to minus B plus minus square root of B square minus 4AC divided by 2A. Therefore, S is equal to minus 2 plus minus square root of 2 square minus 4 into 1 into 2 divided by 2 into 1, which is equal to minus 2 plus minus square root of 4 minus 8 divided by 2, which is equal to minus 2 plus minus square root of minus 4 divided by 2. Therefore, S is equal to minus 2 plus minus 2j, because minus in the square root minus 4 is there, therefore we are getting it as 2j divided by 2. Therefore, S is equal to minus 1 plus minus j. Therefore, number of poles P is equal to 0, minus 1 plus j and minus 1 minus j. Therefore, number of poles P is equal to 3. Now, since there is no S term in the numerator, so number of zeros is equal to 0, that is Z is equal to 0. Therefore, number of branches N is equal to P minus Z is equal to 3 minus 0 is equal to 3. All branches, 3 branches are terminating at infinity. Therefore, step 2, pole 0 plot, and we have to find out root locus region and no root locus region. First of all, S is equal to 0. This is first pole. Second pole is minus 1 plus j. This is minus 1 plus j. J means 1j. J means 1j. Therefore, minus 1 plus j. Therefore, this is second pole. And minus 1 minus j. This is third pole. Now, consider this. First of all, first pole 0. Towards right side of it, no poles and zeros are there. Therefore, towards right side of 0, no root locus region. Now, consider this second pole, or second and third pole, minus 1 plus minus j. Both are at on one linear or collinear are there. They are collinear. Therefore, towards right side of plus minus 1 plus minus j, only one pole and zero number of zeros, that is P plus Z is equal to 1. It is odd number. Therefore, between 0 and minus 1, root locus region exists. Also, towards left side of minus 1 up to minus infinity, root locus region is there. Therefore, this is the root locus region and no root locus region. Here, only root locus region exists. X axis is known as real axis, y axis is known as imaginary axis. Now, third, determine angle of asymptotes. Remember, angle of asymptotes, theta is equal to number of branches 3. Therefore, since number of branches approaching to infinity are 3, therefore angle of asymptotes are 3. Therefore, we have to take values of q is equal to 0, 1, 2. Same case, therefore theta 1 is equal to 2q plus 1 into 180 degree divided by p minus z, which is equal to 2 into 0 plus 1 into 180 degree divided by 3. Therefore, theta 1 is equal to 60 degree. Now, theta 2 is equal to 2q plus 1 into 180 degree divided by p minus z. Therefore, theta 2 is equal to 2 into 1 plus 1 into 180 degree divided by 3. Therefore, theta 2 is equal to 180 degree. Theta 3 is equal to 2q plus 1 into 180 degree divided by p minus z, which substitute value of q is equal to 2. Therefore, theta 3 is equal to 2 into 2 plus 1 into 180 degree divided by 3. Therefore, theta 3 is equal to 300. Now, we have to draw these angles through the centroid. First of all, we will calculate the centroid sigma, and then we will draw these angles. Already here it is indicated that centroid sigma is equal to minus 0.67, but how that value is there we will find out. Therefore centroid sigma, what is its formula? Summation of real parts of poles minus summation of real parts of zeros divided by p minus z. Therefore sigma is equal to summation of real parts of poles. 3 poles are there, 0, minus 1 plus j, minus 1 minus j. Only real values are to take. Therefore 0, sigma is equal to 0, minus 1 minus 0 divided by 3. Therefore which is equal to minus 2 divided by 3, which is equal to minus 0.67. That's why we have to locate the point minus 0.67, and through this point we have to draw the angles. Theta 1 is equal to 60 degree, theta 2 is equal to 180 degree, this is nothing but a horizontal line, and theta 3 is equal to 300 degree. Now next step, calculation of breakaway point. The characteristic equation is 1 plus GHHS is equal to 0. Substitute value of GHHS, that is 1 plus k divided by s into bracket s square plus 2s plus 2 is equal to 0. Therefore s into bracket s square plus 2s plus 2 plus k is equal to 0. Therefore k we are getting it as k is equal to minus s cube minus 2s square minus 2s. Therefore differentiate k with respect to s and equate it to 0. We are getting dk by ds is equal to minus 3s square minus 4s minus 2, equate it to 0. Therefore 3s square plus 4s plus 2 is equal to 0. Therefore calculate its roots by using the equation. S is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Therefore s is equal to minus 4 plus minus square root of b 4 square minus 4 into 3 into 2 divided by 2 into 3, which is equal to minus 4 plus minus square root of 4 square minus 24 divided by 6, which is equal to minus 4 plus minus 2.8284 j divided by 6. Therefore s is equal to minus 0.66 plus minus 0.471 j. As roots are complex, no breakaway point is there. If roots are real, then breakaway point exists. Since roots are complex, then there does not exist breakaway point. Always remember, this is the rule. Now intersection with imaginary axis, step 5. The characteristic equation is s cube plus 2s square plus 2s plus k is equal to 0. By Rauscher method, this is the word, right? S cube, s square, s raised to 1, s raised to 0. This vertical line we have to draw. Then 1, 2. How this 1, 2 is there? Coefficient of s cube is equal to 1, and we have to go to 2s like this. Coefficient of s is equal to, now say s square. Coefficient of s square is equal to, and we have to go to k like this. Therefore k, again s raised to 1. How to find out the value of s raised to 1? Here 2 into 2 minus k divided by 2, that is 4 minus k divided by 2. Here it is 0 because here zeros are there, and again here s raised to 0, here k will be there plus k. Now 4 minus k divided by 2 is greater than equal to 0. Therefore 4 minus k is equal to 0. Therefore k is equal to 4. As k is positive, it will intersect to imaginary axis. Now at k is equal to 4, we have 2s square plus k into s raised to 0 is equal to 0. Therefore 2s square plus 4 is equal to 0. Therefore s square is equal to minus 2. Therefore s is equal to plus minus 1.414 j. So root locus will intersect at plus 1.414 j and minus 1.414 j. Now since complex roots are there, therefore there will exist angle of arrival and angle of departure, or angle of departure only. Therefore step 6 is angle of departure. As our poles are complex poles, that is minus 1 plus j and minus 1 minus j, we have to calculate angle of departure. Always remember, for complex, whenever complex poles will be there, we have to calculate angle of departure. Therefore join all poles to minus 1 plus j pole. Therefore this first 0 join this, and join this minus 1 minus j by minus 1 plus j. Now angle at pole at 0, this is phi p1 is equal to 180 degree minus x. X means what? This triangle only. This triangle. Separately it is drawn here. Therefore 180 degree minus tan inverse of 1 by 1, 180 degree minus 45, therefore phi p1 equal to 135 degree. Similarly phi p2, this is phi p2 is equal to 90 degree, because we have joined this pole with this pole, therefore angle is nothing but with respect to horizontal, angle is nothing, angle of this line, vertical line with respect to horizontal is 90 degree. Phi p2 is 90 degree. Therefore phi p is equal to summation of phi p is equal to phi p1 plus phi p2, which is equal to 135 degree plus 90 degree, which is equal to 225 degree. Now summation of phi z is equal to 0, as no 0 is there. Therefore phi is equal to summation of phi p minus summation of phi z, which is equal to 225 minus 0, which is equal to 225 degree. Therefore angle of departure is at minus 1 plus j. Phi d is equal to 180 degree minus phi, which is equal to 180 degree minus 225. Therefore phi d is equal to minus 45 degree at minus 1 plus j, and at minus 1 minus j, phi d is equal to plus 45 degree. Therefore these two angle of departures are there, minus 45 degree at minus 1 plus j and plus 45 degree at minus 1 minus j. Now we have to draw the root locus. Draw the x-axis as the real axis. Write down the values 0, minus 1, minus 2, minus 3. Draw the vertical axis, y-axis as imaginary axis. Now locate the number of poles. P is equal to 0, P is equal to minus 1 plus j, minus 1 minus j. Locate these poles like this. Then locate centroid minus 0.67. Now from this point draw the three angles. Theta 1 is equal to 60 degree and theta 2 is equal to 180 degree. Theta 3 is equal to minus 300 degree. Now there exists three branches. Therefore first branch will draw from first pole like this. First branch is 0 to minus infinity is the first branch. Always remember. 0 to minus infinity is the first branch. Now second branch will start from minus 1. Now since angle of departure is minus 45 degree, here draw minus 45 degree line. Minus 45 degree, that is angle below the x-axis like this. And what you have to do, from this point minus 1 plus j, you have to draw the line tangential to this minus 45 degree, and you have to draw parallel to the angle of asymptote, because branches of the root locus are parallel to the angle of asymptote. Therefore you have to draw like this, and you have to draw parallel to the angle of asymptote, and it will intersect. Intersection point with imaginary axis is there. We have calculated what is the intersection point with imaginary axis. 1.414j and minus 1.414j. Therefore you have to locate that 1.414 point towards positive side and towards negative side minus 1.414, and you have to see that root locus will intersect the imaginary axis at these 2 points. Therefore this is the first branch. Again here plus 45 degree angle is there at minus 1 minus j. Therefore positive value, draw the angle plus 45 degree, and you have to draw like this so that it will be tangential to the angle of departure, and it will again move like this, and it will intersect at minus 1.414 j, and it is parallel to the 300 degree. Therefore this is the first branch, 0 to minus 180 degree. This is the second branch, parallel to 60 degree, and this is the third branch, parallel to 300 degree. Therefore this is the end of the problem second. Thank you.